Chapter 3, Section 4, Linear and Angular Speed. In this section, we're going to work some real-world problems. Yes, word problems. So, some things that we need to remember are linear speed v. So, v is, when you see the variable v, we are talking about linear speed, is the rate at which a distance is changing in respect to time. So, it's distance per time. For example, when we drive somewhere, we travel at a rate of miles per hour. When calculating linear speed, now linear has a root word line, so straight line, theoretically. When calculating the linear speed traveled around a circle or curved path, one must consider the arc length, s, divided by time. So we're going from linear speed, straight line, to a rotational speed, and so we have to have arc length in there. Now, angular speed is the rate at which the angle is changing with respect to time, not a distance. Okay, it's the angle. So the angle that's changing with respect to time, not your distance. The angular displacement is given by theta in radians. Remember, theta has to be in radians. When the angle is divided by time, you have calculated the angular speed denoted by omega. So when you see omega, you are talking about angular speed. So here are some formulas that you need to write down, you need to know. So the following formulas will be used to calculate linear and angular speed. So angular speed, remember, is omega, and omega is going to be your theta, your angle in radians divided by time. So omega is your angle in radians divided by time. So therefore, omega must be in radians. And then your linear speed, there are several, and we've already dealt with this one, s is equal to r theta. So let's manipulate these. Your linear speed is going to be v, that's your linear speed, is divided by s, remember, arc length, divided by time. And your arc length, if you don't know if you don't know your arc length, you can find it by doing your radius of your circle times theta, your angle. And then you have linear speed is also r theta, because s is equal to r theta, so it's just a manipulation, r theta over time. And you also know that omega is just theta over time. And so therefore, when you replace r theta over t, you're going to get your linear speed can also be found by doing your radius of your circle times your angular speed. So the reason I give you all these is because you never know in a problem what you're going to get, what you're going to be given, and what you're going to be asked for. So it is a good idea to remember all of these formulas so that you can use what you've been given to find what you know. Okay, and we're going to work several examples of this. So first, find t. So we're looking for a time if given an angle and the angular speed in radians per second. So we're looking for t, and we're given theta and omega. So what we're going to do is we're going to look for a formula that has all three of those components. Well, here's omega, your angular speed, is equal to theta over t. So that would be the one that I would use. And so if we know that omega is equal to theta over time, we know that we can manipulate this to be time is equal to theta over omega. And so time is going to be theta, which is 5 pi over 12, divided by omega, which is going to be 8 pi over 9. And we get a complex fraction. We've dealt with complex fractions before, and so let's do skin over guts. So 5 pi times 9, skin, you're outside. 5 pi times 9 is going to be 45 pi over your guts, which is going to be 8 pi times 12, which is going to be 96 pi. And we can see that radians cancel out, and that's a good thing because we need nothing but time. And so we know that 8 pi over 9 is going to be radians per second. And so when pi cancels out, the radians cancel out. And then 9 times 5 is going to be the 45 seconds. And so 96 doesn't have units. And so we have our units in time. So your units can help you figure out if you're setting this up correctly. Alright, and so from here, we can turn this into a decimal. So we'll do 45 divided by 96, which is going to be 0.4, let's do 0.47 seconds. 0.47 seconds would be your time. Okay, so let's look at this one. Example number 2, it says find theta if your time is 12 seconds and your omega is 9 radians per second. So again, we have the same formula that relates these three together. So you have omega is going to be theta over time. But this time we're looking for our actual angle. And so we can manipulate this and say that theta, our angle, is going to be equal to omega times time. So let's plug this in. Omega is going to be 9 radians per second. And we're going to multiply that times time, which is going to be 12 seconds. Okay, so let's look at this. Our seconds are going to cancel out, which is good because our theta needs to be in radians. And so all we have to do is multiply 9 times 12, and we're going to get 108 radians. 108 radians, which is good because theta needs to be in radians. Alright, let's try another one. It says that omega, find omega, your angular speed, if time is 8 seconds and theta is 2 pi over 5. So we know that omega is equal to your angle divided by time. It's the change in your angle per time. So theta is 2 pi over 5 radians, and your time is 8 seconds. Okay, so again, you can do skin over guts if you want to. So we're going to have 2 pi times 1, which is 2 pi. And then that's going to be over 40 seconds. And omega is your angular speed, and so it's you're changing your angle per second. And we can leave it in terms of pi if we want to. And so that's going to be 1 pi over 20 seconds. And so you get pi over 20 seconds. 1 pi radians per 20 seconds. Okay, so here, look at this, where it says find omega if t is equal to 15 seconds, s, your arc length, is equal to 12 pi over 25 feet, and your radius of your circle is 3/5 feet. So we have the same units here, feet. That's good because we've got to have those same units. But we can't necessarily go straight to omega is equal to theta over time. And the reason being is because we don't have theta. So let's see if we can figure out one of our formulas that relates these things. I'm thinking arc length, which we're given, is equal to r times theta, which we know. And so we can find theta by doing a little bit of manipulation. Theta is the same as arc length divided by r. And so let's see if we can find theta this way. Our arc length is 12 pi over 25 feet. And we're going to divide that by our radius, which is going to be 3/5 feet. And again, feet cancel out, which is a good thing because we need it in terms of radians anyway. And so let's do skin over guts. And so we're going to have 60 pi over 75. And of course, that's going to reduce, let's see, I don't really want a decimal. So let's just reduce that fraction, 60 over 75. Let's put that in our calculator. 60 over 75 is going to be, so theta is going to be 4/5 pi. 4/5 pi. And I mean, you can change it to a decimal and get 0.8, but I don't want to do that. Okay, and so now let's go back to omega. So we're looking for omega. Don't forget what you're looking for. It says find omega. Okay, so omega is going to be theta, which is 4/5 pi, 4 pi over 5, divided by time, which is going to be 15. Again, you can do skin over gut, so you're going to have 4 times 15, which is going to be 60 pi over, let's try that again, skin over guts. So you're going to have 4 pi over 75, 4 pi over 75, and time is going to be seconds, so it is radians per second, because this is going to be 15 seconds. So we do have radians per second. Again, you can change that to a decimal if you want to, but I think I'm just going to leave it like that. So this would be your answer, 4 pi. Okay, so let's try this problem, a real world problem. It says find the linear speed, so we're looking for a v. Find the linear speed of a point on the edge of a flywheel if the radius, so here's r, is 7 centimeters, and if the flywheel is rotating 90 times per second. So 90 times per second, what would that be? Well, if we have rotation per time, that's going to be an omega, rotations per time. But remember, omega, it has to be in radians per time, but we have revolutions per time. And so we have a formula that relates omega and radius. You have v is equal to your radius times your omega. And so if we set this up, we're going to have 7 centimeters times omega, which is going to be 90 revolutions per second. Well, remember, your linear speed is the change in distance per time. So we don't need an angle per time, we need a distance per time. And so we need these revolutions to change out. And so if we do, and we do know a conversion here, we know that 1 revolution is the same as 2 pi. So we need it in radians. Omega is supposed to be in radians anyway. So 2 pi is the same as 1 revolution. Now, since I'm looking for linear speed, I don't need that pi to be in my answer. So I need a distance per time. So my goal is to have centimeters per second. And so what I'm going to do in my calculator is I'm going to multiply 7 times 90 times 2 times pi. And then what I'm going to do is I'm going to divide that by, there's nothing but 1s on the denominator, so I don't have to divide by anything. And so what I'm going to have is I'm going to have 3,956.4 centimeters per second. Okay, let's look at this one. A Ferris wheel has a radius of 25 feet. So here we know that we have radius. If it takes 30 seconds, here's a time, if it takes 30 seconds for the wheel to turn 5 pi over 6 radians, what is the angular speed? So we are looking for an omega. What is 5 pi over 6? 5 pi over 6 radians is going to be a theta. And so we're looking for angular speed omega, and we know that omega is equal to theta over time. Well, we don't even need that radius there. So we can just use our theta, which is going to be 5 pi over 6 divided by time, which is going to be 30 seconds, and we know that omega is radians per second. We're using pi, so we know that that is going to be in radians. And so if we do the math on here, skin over guts, we're going to have 5 pi over 180 seconds, and so we are going to get radians per second, so that's going to reduce to pi over 36. seconds. So we get 1 pi over 36 seconds. So that's going to be your omega. Alright, last one. A railroad track is laid along the arc of a circle of radius 1800 feet. That's going to be your R. The circular part of the track subtends a central angle of 40 degrees. That's your theta, but it's in degrees, and we know we need it in radians, so we're going to have to do a conversion there. How long in seconds? That's going to be T. How long in seconds will it take a point on the front of the train traveling 30 miles per hour, this is a linear speed, to go around this portion of track? So we're actually looking for a time. And so there's a lot of things that we're given. We're given a V, we're looking for T, we're given a theta, and we're given an R. So what I would do is I would look back in my formulas and see if there's something that relates all four of these. And we do have that. We have V is equal to R theta over T. And so in order to find T, we're just going to do a little bit of manipulation, and we'll have T, algebraic manipulation, is equal to R theta over V. And so now we need time, and so our goal is to come up in seconds. And so let's see what our units do when we start plugging this in. So R is 1800 feet. Theta is 40 degrees, but we don't need 40 degrees, so let's go ahead and do a conversion. And we know to change it to radians, we're going to have pi over 180. So we have this conversion because we need to change degrees to radians, and just remember that's our conversion that we're going to do. So that's going to be our theta, and then we're going to divide that by our our linear speed, which is going to be 30 miles per hour. Okay, and so we do need to do a conversion there as well, and the reason being is because we need miles per hour in feet per second, and the reason why is because we have feet here per, and we need our answer in seconds. So let's go ahead and do a conversion there as well. So 30 miles per hour, I know that 1 mile has 5,280 feet. So that's going to give me feet. I also know that 1 hour has 3,600 seconds. And so that should work out as well. Okay, so let's work on the top. Let's do our multiplication here. So we're going to do 1800 times 40 divided by 180. And that's going to give us on top 400 pi. And then on bottom, let's do 30 times 5,280. And then let's divide that by 3,600. And we're going to get 44. Now, look at your units. We have degree cancels out degree, so this is actually going to be pi feet. And then on bottom, we have 44 feet per 1 second. And so the feet are going to cancel out. Feet are going to cancel out, and once we do the math, seconds are going to go on top because it is a complex fraction. And so let's do this. Let's do 400 pi, 400 times 3.14, or pi. Let's do that. 400 times pi divided by 44. And that's going to give us 28.6 seconds, and we are rounding. So that one was a little hard. As far as units are concerned, you've just got to know what's given, what you're needing, and how to work the units. Alright, so I'd like you to try these problems on page 132 and 134, through 134. If you have questions, bring them into class.